Welcome. Today we will learn to understand and apply one more type of patterns in angles that will go in our big bag of tricks, of techniques that will enable us to become real wizards in working with angles. The pattern itself will look deceptively simple. And it is simple, but it comes with a warning. I'll get back to that later. So what's our topic? It's any situation that looks like this. So what do we have here? We have two parallel lines, and we have a third line that intersects them both. This is called a transversal, a line that touches two other lines. Now, when we have a situation like this, we will get a lot of equal angles. So let's first look at this angle here in blue. Because this arm is parallel to this line here, we can slide this angle along the transversal until it overlaps completely with this other angle here. Conclusion, these two angles are equal. We call these angles corresponding angles, or you can also remember them as F angles, because the corresponding angles are on the same sides of the short strokes of an F shape, if those short strokes are parallel. I can do something similar for this green angle here. I can pick it up and slide it along the transversal. So for the same reason, these two angles are also corresponding angles. And indeed, we have an F shape here too, only in this case it is a reflected F. Now you already know something else that's going on here. We know that vertically opposite or opposite angles are equal. And there are four pairs of opposite angles here. For example, this angle is equal to this green angle. So that means that these two green angles are equal to each other as well. And we call these angles alternate angles. They are on different sides of the transversal, but both on the inside of the parallel lines. And an easy way to recognize them is as Z angles or Z angles, because they are the inside corners of a Z shape, where the horizontal strokes are parallel. Now, just like the F shape, we can flip or rotate or stretch this Z shape. So we also have Z angles here. Again, on the inside of the parallel lines and on different alternate sides of the transversal. So this angle also has to be equal to this angle and to this angle, of course. So these are the new concepts, corresponding angles and alternate angles. And you probably already see how we can use these for calculations. Let's say I have this situation here, where I know one angle in a pair of parallel lines and a transversal. That basically immediately means that I know all these 7 other angles as well. Let's look at a few of them. I can calculate B, because it forms a straight angle together with the blue one. So it is 38 degrees. I can calculate C, because it forms a pair of alternate angles with B. You see the Z shape or Z shape here. So it is also 38 degrees. And D forms a pair of corresponding angles with the blue angle. You can see the F shape here, long stroke, short stroke, short stroke. So it will be 142 degrees. So you see that the application of this pattern is rather straightforward. However, I also told you that there is a risk. And the risk is that you may see F and Z shapes everywhere now, without taking care to check that the relevant pairs of lines are actually parallel. So in our final example, I will show you both what could go wrong and how to do it right. We have a quadrilateral here, and based on the arrow symbols, it is a trapezium, a quadrilateral with one pair of parallel sides. We have also extended all the sides, so we get a lot of angles. And the question is, which of those angles will definitely be equal to angle D2? Now, the first one will be D4, because it is opposite to D2. And now for the other angles, we will have to look for corresponding or alternate angles. And here some people may think, oh, that's easy. I see a Z shape here. So the inside corners of that Z shape will have equal angles. But that would be wrong. We would only be able to use this Z shape if both of these lines were parallel. But they aren't. So we are not allowed to use corresponding or alternate angles here. We are allowed to use them with these two lines, because these two lines are actually parallel. And then when we use these two lines, we see a rotated F shape here. So C2 will be equal to D2. And we could, for the same result, also have used alternate angles, because we see a reflected Z shape here. So that also means that C2 will be equal to D4. And there's one more identical angle because C4 is opposite to C2, or corresponding to D4, and therefore also equal. So use this pattern, use this technique, but use it carefully. Always ask yourself out loud where the parallel lines are and whether you can actually use corresponding or alternate angles in this situation. Good luck and see you next time.